In the last test, we had this setup here out in the field, and there was a few problems, mostly due to some kind of software problem where it caused the claws at the back there. Let's have a look at these two. Yeah, they moved from side to side to follow the lines of crops, but they kind of oscillated a bit and they overshot. So there's obviously like a timing problem in the code somewhere. So I spent about 2 weeks going through that, finding all the possible causes of that, and ended up going like massively down a quite interesting rabbit hole, really. So on the screen I've created some analysis tools. So one of them was like thermal analysis. Was the system getting hot? Was the Jetson Nano getting too hot and slowing everything down? And this is quite a typical printout here. See, the CPU temperatures never got above 53.5 degrees, and I also plotted the loop speed. So as time went on, I could monitor how the loop speed changed with temperature, and there was absolutely nothing at all. So I could actually rule out temperature as being a problem, which was quite nice. So I've got plenty of cooling in the system. It's not overloading the CPUs too much. Then I did loop speed analysis, so I put timers around the main part of the camera code. And initially I found a massive problem, which is now fixed. So basically, here's part of the loop analysis. I think that's the overall time. I also put separate timers in different parts of the code to try and pinpoint the actual piece of code which was causing the problems, which worked really well. So I was able to find bits in the code to change, to adjust, to optimize. So what was happening, I was getting a random error about 200 seconds in, and the scale's changed on this one. 200 seconds in, basically the loop duration time would like shoot up, it'd double, treble, and then when the cameras became stable again, when there was no movement relative to the images, the loop time didn't decrease again. So there was obviously something really serious wrong with that, and I made so many changes and made multiple changes at the same time, which is always a bad idea, and I've no idea what the problem was, but it's fixed anyway, because now we've got a nice steady loop time, which is just hovers around 0.1 seconds, so it's operating at 10 frames per second. And the other stuff here, this blue line is one of the CPUs, and these other square waves are the CPUs. So there's 6 CPUs in the Jetson Nano. They're all behaving themselves. There's nothing flatlined at the top there. And that's part of the joy of using GStreamer rather than the standard YOLO configuration, which actually flatlines one of the CPUs, which isn't great. It's just if it's used constantly, that CPU is just going to get absolutely hammered. It's better to share it around a bit anyway. So yeah, so there was problems in the code which was causing a lot of delay, and God knows what else was happening. So that could easily explain why it was overshooting. Unfortunately, I couldn't actually replicate the overshooting problem here in the workshop, but I've done so many changes that I feel quite confident that I've fixed that. I've also done something else. I've changed the timings in the way that the Jetson Nano communicates with the 2 MCUs. So I've upped the rate at which those communicate with each other to 10 Hertz. So fantastic. So when we actually turn the system on, we get lots of like rapidly flashing lights. So here's our LEDs. I'm not doing it at the moment because I've not initialized the app, but when I do that in a minute, we can see some nice flashing LEDs, which is always good. So I'm just going to shut this down and turn on the engine. I shut it down because it does tend to brown out a little bit sometimes, although it didn't do last time. Hell, let's just try and run it without shutting it down, because I've got an auxiliary power on at the moment. So I'm going to go and turn the engine on. It's just going to get really noisy. So let's go over here. So right, then ready to start. Where's the camera? Yeah, we've got these little buttons here. Initiate the glow plugs. And turn the engine on. Okay, let's fire up the app. So the intention here is to look at the way that the claws and the camera move with respect to these plants. Before we do that, let's just have a look at some other stuff. It's quite nice. This is the app itself. Lots of possibilities here. The camera's all set up, so there's no need to adjust anything at the moment. Let's look at the telemetry. So we've got our wheel encoders here, getting data from them. So if we were to kind of rock the machine backwards and forwards, just doing that with my foot here, you can see the wheel encoder and the drawing bar encoder just move a little bit. The panel that we're interested in is this one, and I've disabled the graph at the moment. I just don't need the graph to be there. The graph tells us how well we're getting predicted plant locations, that sort of thing. So camera loop speed is going at 0.1 seconds or lower, which is good. That's about 10 Hertz. So I think we're ready to do the test. So we activate the auto weeding button, and at the moment the green, the blue and the circles and the purple square are all fairly close to the centre, so nothing's moving. When it's moving, the white lamp there illuminates. So let's go and have a look, see if we can get this thing working. It should be really nice. Okay, so on our controller here, I'm just going to ramp up the engine speed to get the hydraulics doing something meaningful. Put the controller down. Don't need that. It's all automatic. We're not doing this by hand. So what I'm going to do is to shift the plants relative to the camera. See if the camera moves. Oh, nothing yet. Maybe I need more speed. There's a certain amount of stiction in the hydraulic ram. Should do it. There's not actually any resistance on the gantry itself. It's just pure stiction. So let's try that again. Move that. There it goes. Camera's moving. So what I'm looking for is oscillation, and just like how that oscillated a little bit. It's oscillating a little bit. Is that a problem or not? I don't know. It's not oscillating now. So that's okay. It seems to be quite responsive. It's not oscillating anymore. There it goes. Seems to be alright. No oscillation. I mean, the system's going quite fast. That's quite a lot faster than I'd like. It's probably just because I got the revs too high. So no doubt if the revs were turned down a little bit, even that small amount of oscillation there wouldn't have occurred at all. I should probably do that actually. Let's just turn it down a little bit. Goes, no oscillation. How responsive is it? It seems responsive to me. So I make a small change, camera shifts pretty much immediately. Yeah, let's say that's quite responsive. So whilst we're on the subject of the engine revs and the stiction and the RAM, there's a plan to replace some of the valves which operate this cylinder here, which is the sideways shift, and also this one here, with proportional solenoid valves, which are about 10 times the cost of the ones at the moment. The ones that I'm using at the moment are what called a sort of bang bang on off, so they're quite crude, and it's amazing that I get any sensitivity out of this system at all, really. It's just, when I'll do this I don't know. Very expensive pieces of kit, and yeah, 10 times the cost. I think it's like something like 2,000 quid or something, absolutely ridiculous. So next stage here is test it out in the field again. Just try and remember not to have the revs running too high, because then the camera does move too fast. But when we get these nice expensive proportional valves in place, we won't even have to worry about that. They'll work it out with sales through software, and they even create like a vibrating effect on the hydraulic cylinders themselves to overcome stiction. So the cylinders are vibrating at a certain frequency all the time, like just ready to move in either direction. So you'll get absolutely instantaneous movement. And I could probably do things like reduce the deadband and stuff like that, make it highly optimized. So I don't know if I've talked about this, but the function of this thing here is basically to extend this drawbar here, and what that does is it momentarily stops the wheels dead in their tracks with the help of the encoders. So there's a wheel encoder down there somewhere, can't really see it, and there's another encoder on this RAM here, and because we can measure everything in real time, and if we've got these proportional control valves, we can adjust the speed of this cylinder here to effectively stop these wheels dead in their tracks and enable the claws just to wiggle sideways a little bit, and that's enough. Just that little wiggle's enough to cultivate or to disturb the soil between the crops. So at the moment everything's set up to do what we call in-row cultivation, so the claws will come this way. So the claws will come this way in the x-axis, but with this little wiggle and the drawbar cylinder, we can also do a sideways cultivation at the same time. So because of the orientation of the claws will basically weed this little gap here. It's only a small gap, but important. If you've got stuff there, you want to get rid of it. It's just a little wiggle, and then the drawbar retracts again, and the system's ready for the next iteration. So that's like a whole new thing. I'm just trying to get the in-row stuff working at the moment. I don't think I can really do this task here with the retractable drawbar until I've got those proportional valves and electronics in place. But that's all good. I think that will happen at some stage. Let's see. Right, so I think the next thing to do is go out in the field again. Give this another run for its money. Okay, we're back in the field again to try and do a test. Got the auto weed on. I've got the system recording the actual GUI interface as well, so I can see or we'll be able to see like a pop-up video in the top right hand corner with what the computer's actually seeing, which should be quite handy. I think there's a little bit of sunlight which has just come out, which is a bit of a shame, but yeah, let's just see if we can get this system working. So again, camera operation is really difficult. Let's just see if we can do it. I have done it once and it works, so let's hope it does it again. Right. Edge it forward, nice and slowly. That's a good speed. Right, they've made an adjustment there. So I'm watching a red light, a white light and white lamp on top of the machine. Made another adjustment. So you should be able to see like a red vertical line in the screen, in the pop-up screen, and the green, blue circles and the red, the purple square control the claws where they're going. So at the moment it's making plenty of adjustments. Looks fairly good. Quite close to one of the cards, but it's okay. I think that's alright. Made an adjustment there, I could see that. I've actually got a master adjustment as well, so I think the claws just seem to be a little bit close on one side, so I'm just going to try and adjust that, see if that moves it the right way. Probably not, no, that's the wrong way. Let's move it the right way. Let's try that. Yeah, that's better. That's pretty much spot on now. Just made an adjustment on the screen on the GUI to bring those green, blue circles and the purple square onto the vertical red line, and that's lots better. Yeah, it's working nicely. I'm also looking at the camera loop speed because I had a lot of problems with that, and that seems to be pretty fast. It's looking at about 15 frames per second. So I don't know if you can see that on the camera, but claws are nicely in line with the rows of cards. It is picking up the cards a little bit. Won't miss that one. But if that was a plant, it just wouldn't destroy the plant. The plant wouldn't care. So these claws are, there's a gap of 25 millimeters for the actual plant itself. I'd say at the moment they are working on accuracy of about 5 millimeters. Yeah, I'd say so. That's pretty good. The only way to improve that is to use a proportional control valve on the side-to-side hydraulic ram, but it's working okay, it's fine. The proportional valve overcomes the stiction, so we are suffering a little bit from stiction here. So what the proportional valve system does, it vibrates the hydraulic cylinder slightly so that it's ready to move, and you get massively precise movements down to probably less than a millimetre with those valves, and they're very expensive, so it'd be great if I didn't have to buy them. So at the moment we're doing really well. The test is looking quite successful. It's making loads of adjustments. Be able to see it on the video in the top right screen again. Just orientating to that vertical red line over and over again. Because although I've planted them in a straight line, they will deviate slightly. You get uneven surface on the wheels themselves, so it rocks from side to side. It's just like a... And we're coming to the end of the test. We've run out of cards, and that was 100% successful. First time ever that I've managed to do that, so I'm really pleased with that. End of the test.